Hi everyone, in this lecture I am going to discuss about electrophoresis. Electrophoresis is a technique which is used to separate a mixture of organic compounds like proteins, amino acids and some other organic compounds with the help of electric field. The electrophoresis is done with the help of voltage applied to the electrodes, that is positive electrode and negative electrode. Cathode is a negative electrode which attracts positive charges towards it, whereas anode is a positive electrode which attracts negative particles towards it, and the separation or migration is done with the help of electric field, as the compounds will migrate towards its opposite charges or polarity. Introduction to paper electrophoresis. Paper electrophoresis is a technique where paper is used as a stationary phase. Here in case of paper electrophoresis, Wattmann filter paper number 1, that is grade 1, is used for electrophoresis. It will we have to apply the sample at one spot, and when we use electric current for supplying voltage in the presence of buffer solution, all the components will migrate towards their respective electrodes. And the principle of separation here is electrophoretic mobility. Electrophoretic mobility means under the influence of electric field, the molecules that are present in our buffer system will be separated as per their charges towards their respective electrodes, that is cathode or anode. So that principle is called as electrophoretic mobility. We will be having a mixture of ions or ionizable substances as our sample, and they will be applied in the middle of the electrophoretic system, that is the stationary phase. And when we apply the voltage after immersing the stationary phase inside buffer, the solutions will be separated, and the separated compounds with neutral or Zwitter ions will stay in the middle. As they have no charges, they will not move in the buffer system towards either of the electrodes, that is positive or negative electrode, but the positively charged compounds will start moving towards cathode, whereas the negatively charged ions will start moving anode. So this is the basic principle behind the separation in electrophoresis. Then the principle of electrophoretic mobility, here it is clearly defined that when we apply electric field 1 volt per meter, the particles will move, the movement will take place per meter per second, and the rate of movement is given as mu is equal to V divided by E. The formula for electrophoretic mobility is mu is equal to Q divided by 6 pi eta R. So it clearly states, it is a Stokes law, it states that the electrophoretic mobility, that is mu, is directly proportional to Q, that is net charge of the ion. So which means when you increase the size of the ion, then its electrophoretic mobility, when you increase the charge of the ion, its electrophoretic mobility will be more. For example, consider we are having calcium Ca2 plus and sodium Na plus. Here the calcium is having more charge as it is having 2 positive ions. So as per this formula, the electrophoretic mobility will be directly proportional to the charge. So which means the calcium will be moving faster. But you can see the eta, that is viscosity, is in the denominator, and also the radius, ionic radius of the solute is also in the denominator, which clearly indicates it is inversely proportional to the electrophoretic mobility. So which means if the particle is having a bigger size, if it is having a high radius, it will move at a very slower rate, but if the particle is very smaller, then it will move at a faster rate. And the movement is also dependent on the viscosity of the medium. So viscosity of the medium means it indicates the buffer solution we are using for analysis. If the viscosity is more, then the movement will be lesser, but if the viscosity is less, then the movement will be more. Then the mobility. The mobility is faster when the molecule is having high charge, and it will be medium if it is a larger size, and in case of high viscosity solutions the movement will be very less. The compounds of electrophoresis are filter paper, electrodes and voltage and buffer system. The filter paper we can use is Wattman of grade number 3 mmR number 1 filter paper with its dimensions 2.5 to 5 centimeter width and length to touch the buffer system. And first we have to wash the stationary phase, that is filter paper, with double distilled water, and again we have to wash it with 0.1 molarity of HCl, and then we have to wash it with 0.01 molar EDTA solution. Then the electrodes and voltage are necessary part. The electrodes consist